what's it called, the test, and seniors who are flaky. Again, one more time, it's going to look like this. I'm going back and forth because I'm just telling you how to set it up, and then you're going to put your pencil down and watch something, and then I'm going to give you the formulas, right? So I'm just getting your formula sheet set up for you, right? Because it'll make sense as we do it. Because everyone's got their formula sheet ready to go, pencils down. The next thing we do is, for some of you, when Thomas went to Cal Poly, so you do all know that somewhere you must take a computational class in college to graduate from college. You cannot go to college and not take a math class. They won't let you. There are multiple ways of meeting that computational requirement. For most of you, your statistics class will do it, because if you're going to do something that is not math or science, then you will need statistics. So he needed a stat class for poli-sci, because you do statistics and political science. My daughter did anthropology, and because you use statistics to do all the research, she took 3 statistics classes, because she was going to go to grad school, so she needed harder statistics. But my oldest son, took just trig. He didn't even need. He was a geography major, and he actually had stat. That was a separate requirement, but he needed one more math class at Cal Poly, and he took just trigonometry. A quarter was just trigonometry, and that's another way that you can meet this requirement. And what we're about to do today is kind of a big foundation piece of that, if you ever take it. If you're going to do business or any kind of science, my loves, you are heading to calc at some point. And there's 2 ways to get there, because I'm talking to all seniors. This is great to be able to do this. You can do it in 1 step, or you can do it in 2 steps. My advice is the 2-step process, but if you want to go to 1 step, you can. 1 step is to say, I've taken pre-calc, I am ready to go straight to calculus. But the truth of it is, this is high school pre-calculus. There is college pre-calculus. You didn't take that. That's AP pre-calc. We took high school pre-calculus. I believe what this class does is best prepare you to take college level pre-calculus and get a really good grade, and then go to calculus. It would be my advice to take it in 2 steps. Here's why. When you get to college, the vast majority of kids who take calculus here don't always get a great score on the AP test, because most colleges for calculus will not give you the credit without a 4 or a 5. So what happens is, you get to college calculus and everyone sitting around you has already had calculus. Does that make sense? Because they all took it in high school and you're like, wow, I didn't even take college pre-calculus. So my advice is to take it in 2 steps. Take pre-calculus and then start your calc series. But you do you. If you're feeling like, I got this, I'm ready to go straight to calculus, just know that it's a pretty sizable jump, even from doing it here, because when I was at Cal, every single kid sitting next to me had already had calculus. I did too. I took calculus in high school, and then we took it in college. Okay, that was just an aside for you seniors. But you know what? If you're not going into math and sciences or business, you are welcome to do this with statistics or trigonometry. Okay, so here's our last bit of these weird IDs, our weird identities. I need you just to watch this, pencils down, and Jillian's watching me. There we go. So here's what I'm going to tell you. I'm going to tell you a weird thing happens on our friend Mr. Unit Circle. On our friend Mr. Unit Circle, I'm going to tell you right now, that's 60 degrees. How do I know that? Because I decided it's 60. And I went to my handy-dandy unit circle, because God knows I have a hard time remembering these. I'm going to talk for a little bit. And then I'm going to know that that point right there is 1/2 and root 3 over 2. Yay, that's true. And you all know that. Everyone in this room knows that fact, right? Because you had a unit circle. You have a unit circle. And I know from the problem I just did I just did that I should be able to drop a little line right here and make a little baby right triangle. And I should be able to do Pythagorean theorem with this guy being 1/2 and this guy being 2. That should work. And I'm going to try it, and I'm going to see what I get. I'm just going to go a squared plus b squared and see what the hell my radius is. I'm going to see what happens. So I'm going to say 1/2 squared plus √3/2 squared. And right now you're thinking, oh my God, Miss P, those are going to be nightmare answers. But they're not, because watch what's going to happen. 1/2 times 1/2 is 1/4. √3 times √3 is just 3. He gets freed from jail. 2 times 2 is 4. That's not terrible. 1/4 plus 3/4 is 4/4. It just equals 1. And that makes sense because this dude is the unit circle. And everywhere on that baby, that radius is 1. So what I'm telling you is it didn't just happen here by luck. It happened at every single one of these freaking points. I could plug it into a squared plus b squared and get 1 every single time. And there is something I can get out of that. So Josh, I need you guys to kind of pay attention. There we go. Thanks. So here's what I'm going to tell you. Here's my big finish here on this. My big finish on this is this. It doesn't matter where I am on this baby. I know from you guys telling me last week, this guy is always cosine and this guy was always sine. So here's what I know now. I now know that if I have cosine and I square it, and I add sine and I square it, no matter what, in the whole universe, it will always equal 1. And that's our final weird identity. So that's where it comes from. I could show you where the other ones come from, but you don't care. But now you know, I'm just not pulling this stuff out of my butt. This is where it comes from. So what I'd like you to do right now is I'd like you to have those 3 lines, line, 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 and you're going to put 2 dots underneath each line. So it should look like this. Line, 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 dot, 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 dot. Is that okay? We're going to put a formula. Formula. Is that cool? Yeah. Okay, perfect. Love that. Okay, our first one is the king of them, and you're going to use him so much, you're going to have him memorized because he is just like a little slice of awesome. And there he is. Now, here's a couple things you're going to notice. Someone in my A period asked me, why the hell are you putting the squared in the middle and not next to the little angle thing? And here's why. Did you notice on that 60-degree one, I never squared 60? I didn't go 60 times 60. Nowhere. I didn't do that. That would have been like 3,000. I squared the cosine part. So we are just squaring this dude, not this one. That means these will work for any angle in all of America and the universe. So sine squared plus cosine equals 1. Now, I want you, there are highlighters at most of your desks. If anyone needs another one, there's one on the floor. They're all over. There's a few others. I want you to highlight some parts of him. We're going to need to watch for this dude. And here's a tip by my dad. What we're going to be watching for is a squared, a plus sign, and a 1. They might not have everything. They might have the 1, and they might have the squared, or they might have 2 squared and not the 1. But you're going to watch. Are you good? Yeah, you're so cute. You're going to watch for those. That means that's going to be a trigger for you to say, oh, get my magical note sheet out. I bet it's one of these dudes. Now, we can mess with this guy. We're going to mess with him in 2 ways. The first way that we're going to mess with him is we're going to say, let's see if we can just get sine by himself. So we're going to say sine squared theta equals 1 minus cosine squared. All I did was move that guy over. That's all I did. He's not really a new formula, and you have this sheet to use on the test, but you got to watch for him, right? It's not that you have the sheet, it's that you know how to use it. Now, there's one other dude. We can also get cosine by himself. And you know what I'm going to do that? I'm just going to move sine over. So can you try doing that all by yourself? So it's going to be cosine squared theta equals something. That's it. 1 minus sine squared theta. Beautiful. Beautiful. Love that. Okay. Now I have to be honest. I have those memorized. Those ones I know because you just use them so flippin' much. I'm going to show you 2 others. And I don't have them memorized, but I recognize that I need to go to my magic note sheet, right? They're like, oh, they're a trigger for me. Like, oh shit, I got to go look at that folder I discussed. I got to go look at it. So here comes the next line over. Are we okay? So the next line over is going to look like this. Here comes the next one. Here he is. Boom. He's this dude. And you know what? He comes from the other dude. But I'm not going to show you it because no one cares. This is the second row. Yep. Here's the thing we're going to highlight. The things to watch for on this dude. Again, squareds, another 1, right? And then I tell myself that tangent and secant kind of go together. They're little buddies, right? So if I see like a tangent squared on a 1, I'm going to be like, oh, shoot, I think that's one of my dudes to go look at. I never have him memorized. I mess them up all the time. So I have to go look at him. We have some friends for him. Here's one of his friends. Watch what I'm going to do. I am going to do this. Oh, he's kind of weird. I'm going to say, here's our first one, secant squared minus tangent squared equals 1. You know what I did? I just moved this dude over. I just moved him over. Because sometimes we like the 1 all by itself. And there's one last one that I'm going to put on here. I've got secant by itself. Now I'm also going to do, so secant's by himself over here. I'm going to get tangent by himself. Tan squared equals, do me a favor, can you figure out yourselves what is tan squared equal to? Move the 1 over. If you got secant squared minus 1, you're awesome. I'm not going to lie. I don't have those ones memorized. Every year, I'm like, damn, I always mess that one up. We got one last one to do, and I think maybe you can see what's going to happen. On this one, I did tan and secant. So now I'm going to do cotangent and cosecant. So if it's okay with everybody, I'm going to move this dude out. Get out of here, dude. I'm going to move him. Come on, you. Boom. Here comes our last one. And then we're going to play the game. We're going to play the game. Okay. First partner of his, I'm going to try getting that 1 all by itself. I want to get everyone by themselves at least once. So I'm going to say, hey, what if I get 1 by itself? And I'm going to say cosecant squared minus cotangent squared equals 1. I just moved this guy over. That's all I did. Again, you don't have to have these memorized. You just got to know how to use them, and you got to know to watch for them. And the last one, talk to me. Yeah, so same thing, squares, a 1. Yeah, that's the, and that there's going to be a plus or a minus in there, like you're going to watch for that. And you'll see when we start playing the game, you'll be like, oh, I get it. So the last one, cotangent squared theta equals cosecant squared minus 1. So our last thing to do on this, we're going to do it for like 4 days. We're going to play a game. And I like this game because it's math without numbers. Literally, it is math without using numbers. And I want to start you off by talking to you about this fact. This is this because I say so. That doesn't have any real meaning. I just decided that this equals this. I mean, let's be honest. This makes more sense, but we don't do that. And if I asked you what this plus this, if I could squish it down, you would make it into this. You would make it into, oh, look at me do it right. You would make it into this. Because you're doing representational thinking. You're doing math with these weird little symbols. But you are not in kindergarten. You don't write down the little hash marks. And you don't pull your fingers out and go, 1, 2, 3, 4, 5, 6. Like, you don't do that. But that's how you used to do it. So here's what we're going to do. We're going to do the same thing here. We're going to do math with words. I like it better because I don't make any computational mistakes. But I need to tell you a couple of things. First thing I need to tell you is, I think that if you had an Algebra 2 trig teacher last year and you struggled with this, it is because they didn't give you enough of these to practice on. So I handwrite, or Mrs. Tarantino writes a ton of them. But it's really hard for me to do the theta when I'm word processing. So often I use X. And I don't want anyone to freak out and be like, what happened to beta? I just changed it with X because it's easier to type. Second thing is, remember how we did logs and I said, I'm so lazy, I just do this, ln, because I'm that lazy? Okay, I do the same thing when we start rolling on these problems. I start just leaving the theta off altogether. At the end, do I put it back in my problem nicely? I do. But I don't want any of you to freak out and be like, Miss T, what happened to the X? It just disappeared. I'm like, yeah, sorry, I got excited, right? Okay, so we're going to play a game, and I'm going to tell you, you've got rules right there, and we're going to practice some of this. Our job is to take something that looks like this and get it down to one word, right? We're going to get it down to one word. So we're going to do about 6 of these. Whiteboard desks are a separate sheet of paper. I don't care. Don't do them on your magic note sheet, okay? Don't do it on your magic note. Because the magic note sheet's just going to be horrible. I do. There's some right above you there, and there's some right over there. Because you're right. I hate doing math on my paper. Oh my God, you're a terrible person.
Wait, I want to be on my desk. I like writing.
I do too. I do too.
What did I do?
Okay. First rule of Fight Club is we don't talk about Fight Club. Second rule of Fight Club is remember when you did proofs of geometry and you wrote the given down and the teacher said, what do you do next? And you thought, I don't know what I do next. It's kind of like this. I'm going to give you a hint of what you do next. So if I said, condense this down to one word, you'd look at me and be like, I don't even know how to do that. So one of the biggest hints I can give you is this. Let's use words that we like. And the 2 words that we really like are sine and cosine. So could you do me a favor, please? Can you rewrite these 2 things? They are times together. Can you write that with the word sine or cosine instead of cosecant? And can you write that with the word sine and cosine instead of tangent? Where do I get those from? My reciprocals. There you go. You know what? I feel like you just got the whole thing right there. Like literally, you're going to write it and you're going to be like, I get it now. 1 over sine theta. I keep forgetting to put him. And then sine theta over cosine theta. This is math. Can anything cancel? The sine and the sine. 1 over cosine. We don't get to end in a fraction. We're simplifying. What is 1 over cosine? It is secant theta. That's the answer. You just played the game.
That's it.
You win. Yep, that's it. We just make it more and more complex.
So what, the theta's actual value?
It could be any value. If I put in any value, you could simplify this to do this. If I put in my calculator a 10 degrees here and a 10 degrees here and get a number, I could have just put it in that and I get the same number.
Oh, but what if cosecant that is 10 degrees for you and tangent is like 11 degrees?
They're going to be the same.
So everything's always going to be secant theta.
For this, yes. So it's like saying this. Will that ever be anything other than 6? It will always simplify to be 6. This would always simplify to be that. Always, always. And you could use it for, What does that equal? What is X? Anything you want it to be. 10, 20, 50, a million. It would always be 6X. Does that make sense? We're doing the same thing. Just instead of using 4s, we're using words. Okay, next one. Here we go. Let's try it. Okay. I'm going to have you try it yourself. Oh, I got lots of words up there, but very few of them are sine or cosine, and I like sine and cosine. Those are my friends. So could you do me a favor? Could you rewrite them with sines and cosines? Now, some of you are thinking, Miss T, you warned us to watch for the squares, but I said there has to be a plus or a minus, and there are no pluses and minuses in this one. So I'm not going to use my Pythagorean ones. I'm just going to, so first I look for those Pythagorean ones, but there's no pluses and minuses, so I can't use those. So now I go to my fallback position, which is rewriting it in words I like better. So cosecant is 1 over sine squared. There's 2 of them. If you want to write sine, that would be awesome. You don't have to. Tangent's going to be sine on the top, cosine on the bottom, and then you're going to have just another cosine.
Wait, I think I'm doing this wrong.
Everyone okay on this?
Wait.
You don't have to do this way. You can do it square, but I'm just showing everyone in a minute where I start doing some cancely.
Did you just see? I don't
Yeah.
know when we use the reciprocal identities versus the quotient identities.
So you want to rewrite that. So I know this word. I need to rewrite that. I don't like tan.
Yeah, but there's 2 tails.
Okay, so which one gives me sines and cosines? You see what I'm saying? Yeah, I'm defaulting to stuff I know. Okay, are we ready to watch a little cancel action? Are you with me? Cosine's already done. I don't have to do them again. I had a girl in my last class who kept rewriting things. She took this cosine and rewrote it as 1 over secant, and I thought, oh my God, you're trapped in a loop. She just keep rewriting them over and over again. No, write them in sines or write them in cosines. Don't keep rewriting them, right? Now let's cancel. Boom, 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 yay. One of these cosines with one of these cosines, yay. Here's what I got. I got 1 on the top. I got cosine theta on the bottom. I need it not to be a fraction. It is again, secant again. Secant theta. Do you see how it just gets more complex? Yeah? Are we good? Okay. We're going to step up our game a little bit. Okay. Advice on this, do top and bottom separate. Take a look at your top, take a look at your bottom as 2 separate things. Now the top, look what I got going on here. I've got a squared and a minus or a plus. Look at your Pythagorean ones. This is a sine. Maybe it's one of those. Don't look at sine and squared and cosine squared. I've got the word secant squared and tangent squared. Look at that and see if you can rewrite that using that Pythagorean. It's a nice thing. Okay, I like that noise. So did you get one? So first thing is, did you get one for this guy? Oh, for down here? No, it's Pythagorean. Look for your Pythagorean one. It's just one. You see why? It's just one on the top. No, no. So here's what. Squares and minus. That's a hint to go to your Pythagorean one. Look at your, where's your Pythagorean one? Use this out, yeah. Okay, so what is it? Oh, that's supposed to be. Oh, that would have been right. And then oh, that's it. I'm not done yet. I'm not done yet. I got this. I'm not done. Now I'm going to say sine over cosine times cosine over 1. How about a little bit of cancel action?
Are you forgetting to write the thetas right now too?
Because I get excited. So I got 1 over sine squared. I'm not allowed to have fractions at the end. I can spell that. So this crazy big thing simplifies to that.
Oh, this is like the type of balls we get on the test.
Yes. There's one last piece that we do on Friday where it's called verification, but it's, I give you the answer and the problem, and you have to show me how you get to that specific answer. It's easy. It's just showing your steps.
Oh, also showing your work.
That's all it is. You know, you do realize that's all the proof ever was just showing your work, right? Okay. No. Okay, now, I need everyone's attention on this one. Remember, we're just doing math. We're just doing math that we know how to do with words. So, before I start this problem, I would like to know, could you talk to your neighbor if I said to you, could you please factor something out of that? I need everyone to look at this. Ron's watching me. Could you factor something out just because you're far in my line of vision? That's all. I can't see everyone. I can literally not even see Sarai. She could not even be there. Could you factor something out of this for me? I'm going to take out an X, right? What would I have left? 5 plus X squared. Guess what? You know how to do this math. Anytime, here's my new hint, anytime you have a power over 2, you are going to factor it. So watch what I'm going to do right here. I am going to look at this guy and say, he's got 3 cosines. He's got 1 cosine. I am going to factor out a cosine. So the cosine comes out. I want you to turn and talk to your neighbor to see what's left here. It's a hint. And what's left over here. Goes down 1. This, so really what this is like 5. Oh, wait, watch this. It really is like this. 5. Let me do it like this. X 5 plus X. That's 3. You see what I'm saying? I can take out his cosine and his cosine. This is your married point. This stuff is one thing. This stuff is one thing. Does that help?
Oh, I see.
Yes. Good question. That was a great question. Okay, watch what I get. Oh, I love this answer. I get sine squared and I get cosine squared all over sine. I'm going to take a breath real quick. And I want you guys now, because you're thinking, Miss T, I can't change anything into sines and cosines anymore. So what the hell's happening here? Look in your parentheses. Does it have squares? Does it have a plus or a minus sign? If it does, Go to your Pythagorean choices. Look right now in your paper. I can't chew that food for you. Go look. See if sine squared plus cosine squared is a thing. It equals 1. I wrote it as cosine squared plus sine squared, but could you flip it around? You absolutely could. You see it? So they just kind of go away and become 1, right? That just becomes 1. I'm doing 1 times cosine. So here's what I have. I have cosine on the top, sine on the bottom. I think that's a thing. Right. Cotangent. Does it take practice? It does. Today, you're going to be like, eh. Tomorrow, you're going to dial in. I got one last one as I'm passing out your homework. So, I'm going to tell you what. I did this problem last year, and I did it with factoring. I factored a bunch of stuff. And then I had another student who said, Miss T, I got the same answer as you do, but I did it a completely different way. And my answer to all of you is this. Good for you. Because there are lots of ways to approach this. I think the easier way to do this problem is to rewrite the tangent, do a little cancel action, and then see what you got left over here. But I did it by factoring a hard way. I took out the cosine and the cosine, and it was much harder. Don't do it my way. Do it a smart way. Give it a try. And I'll tell you what the answer is in a minute, and I'm going to give you your homework. We do this for 2 days. No, wait. Because it's weird. So, sorry, juniors, you got some catching up to do. Bye, friends.